In this video, we will find the measure of center, which includes the mean, median, mode, and mid-range in a set of given data. So we are given the data here represents the first 11 wait times in minutes for Space Mountain at 10 a.m. at Disney World. So to find the mean, which most people think of as the average, you're simply going to add all the values in our data set here. So 50 plus 25 plus 75 and etc. And then divide the sum by the number of values in the data set. So we have 11. This is an example of a sample mean, so that's why we use X bar. So the sum is 430 divided by 11, and so we said that the typical waiting time for Space Mountain at Disney World is around 39.1 minutes. As you can see, the mean considers every single value in the data set, so one of the important properties of the mean is that sample means drawn from the same population tend to vary less compared to other measures of a center. However, one disadvantage of the mean is that it's sensitive to outliers. In other words, just one extreme value or outlier in the data set can significantly change the mean, so therefore we say the mean is not resistant. The median is the middle value in a data set that is ordered from least to greatest. To find it, you first need to arrange all the values here in an ascending order. If there is an odd number of values, which in our case is 11, the median is the value that is exactly in the middle of our sorted data here, which is 35. If there is an even number of values, the median is calculated by taking the sum of the two middle values in the list and then divided by 2. One important property of the median is that it's resistant to outliers. This means that the median is not heavily affected by a few extreme values in the data set. On the other hand, one limitation of the median is that it does not directly use every single data value in the data set. The mode is the value or values that appear most frequently in a data set. A data set can have no mode, one mode, or multiple modes. For example, for our data, two values appear with the same highest frequency as 25 and 50, so therefore we have two modes here, and we call that bimodal. If more than two values appear with the same highest frequency, then we call that multimodal. The mid-range is calculated by adding the minimum plus the maximum and divided by 2. So we get 95 over 2, which is equal to 47.5. While the mid-range is very easy to compute, it has limitations. The mid-range is very sensitive to extreme values in the data set, so it is not resistant to outliers. As a result, it's rarely used in practice. It is important to think critically about the data, whether calculating the measures of the center makes sense. Just because we can calculate these measures, it doesn't always mean they're meaningful. For instance, calculating the mean or median of zip codes or jersey numbers is not meaningful because these numbers are labels or identifiers and do not represent any measurable quantity.